Hello students and welcome to the next module of basic definitions. Students, in the last module we introduced elasticity and then we said that there are going to be a few basic definitions that we'll be studying in the next module. So here we go. The first definition is going to be for a rigid body. Students, rigid body. Doesn't the name itself suggest that this body is going to be rigid no matter to what force you are exerting or exposing this particular body? So here we go with the definition. Rigid body is a body whose shape and size or does not change even if a very high force is applied. That means no matter how much force you are exerting or how much pressure you are exposing a rigid body to, this rigid body is not going to undergo any change in case of shape and size, or in the other way as shape or size. Let us have a look at the example, students. The first example is diamond. Obviously, students, the hardest material known to man. Second one would be a steel spear. Now a steel spear, a solid steel spear which is filled to the core with pure steel. No matter how much force you are exerting, students, there is going to be some deformation. See, what happens in case of a deformation? Sometimes what happens is, in spite of a change of shape, the object or the body actually breaks down as well. So what do? No body is rigid for practical purposes. But just to assume, to make our experiments and our calculations possible, we assume these two bodies to be completely rigid. So here I have my statement. No body is rigid, but for practical purposes, we assume a diamond or a steel spear to be a rigid body. So students, over here we have seen a rigid body and what actually is important to understand a rigid body. Now let us go ahead and go for the absolute opposite of the rigid body, that is non-rigid body. So by this time, students, you can guess the definition of non-rigid body. That is, the non-rigid body is a body whose shape and or size changes due to a force applied. That means if you are applying a force, the shape and or size of this particular non-rigid body is going to change. Let us have an example. Rubber band. Students, rubber band would be the most simplest examples. The moment you exert a pressure on it, it extends. The moment you release it, it goes back to its original place. Also, students, one more example would be of a steel or iron rod. Now students, in day-to-day life, we actually don't try to bend a steel or an iron rod. But students, it is possible. There are machines that can actually bend irons into desired angles, and these iron rods are actually used for construction purposes and also for many machine purposes. Let us quickly go ahead, students. Elasticity, the most important definition for us. Elasticity is the property of a body by virtue of which material bodies regain their original dimensions, that is size, shape, or both of them. Material bodies, that means solids, regain their original dimensions. So suppose if initial dimension of a rubber band was 5 mm, you stretch it, you take it to 10 mm. If you are releasing it, it is going to come back to its original position. Same case would be with the spring. You press a spring and the moment you release it, it regains the original dimension. So students, here is the meaning of regains their original dimension after removal of deforming force. Once again, students, the original dimensions will not be regained unless until you are removing the deforming forces. So here, students, is the definition for elasticity. Now as you can see, deforming force is applied, but the moment you are releasing that force, that particular object is coming back to its original state. The same case is in case of a rubber band as well. So as you can clearly see, it has to regain their original dimensions. Then only a particular object will be known as an elastic object. Let us go ahead and do the opposite of elasticity, that is plasticity. Plasticity is a property of a material to undergo a permanent deformation even after the removal of external deforming forces. Don't rack your brains. Just see the example and you'll understand. So here we have two examples of clay and wax. The moment, students, you are molding a clay pot, does it happen that after drying, that particular clay or that particular clay pot is going to change its shape the next day? Absolutely no, students. So once a deformation actually takes place over here, what happens is that is restored as a permanent deformation. So as you can see the words highlighted in red, permanent deformation. So in your definition of plasticity, this word permanent deformation has to be there. Thank you, students, and I will see you for the next module.